Today we're going to do an activity that will illustrate several different random sampling methods. So here's the situation. Suppose we want to estimate the yield of our cornfield. The field is square and divided into 16 equally sized plots, 4 rows and 4 columns. A river runs along the eastern edge of the field. We want to take a sample of 4 plots. So the first one we're going to do is a simple random sample using a random number generator. So we have the plots numbered 1 to 16, and what I did was I used my random number generator on the calculator, first doing a random seed so I wouldn't get the same value as other people in the group, and then did random int 1, 16 and did it 4 times, and I happened to get 4 different numbers. If I had gotten a repeated number, then I would have done a 5th or 6th number as needed. So I needed 4 different numbers, 13, 14, 16, and 6. So I circled those 4 values. And I'm going to do something with those again in just a minute. Okay, now I'm going to do a different type of random sample. It's called a stratified random sample. I am going to randomly divide the field into 4 rows. And I'm going to randomly pick 1 plot from each row. Now in this case I can get repeated numbers because I'm just saying I'm picking 1 plot from this row, randomly 1 from this row, randomly 1 from this row. So I can, just as long as I get 1 from each row, it doesn't matter if numbers repeat. So on the calculator then I did my random integer 1 through 1, 4, and then I had the numbers 3, 4, 4, 3, and so that's what I used. And then in the third plot here, I did the same thing, only I randomly picked 1 from each column using the same method, using the random number generator. And then the question arose, okay, which of these methods is best? And after a little class discussion, we decided that number 3 is best because the corn yield is probably going to be higher near the river and lower farther away from the river, so it would make sense if we want a representative sample to get 1 plot at each distance from the river. So we're going to go over to the next page and see now what happens when we know what the yield is in each of these plots. So here's the yield in each plot. Okay, now I'm not going to go back and do mine in particular because I'm going to show you the class results. So what we did here is, let's say, for example, here's my original plot. So let's say I happen to have picked this plot, this plot, this plot, and this plot in my random sample. Then I would look at these 4 numbers here, add them together, and divide by 4, and that would be my average yield that I would get from my random sample. So I had students do that for each of the 3 samples that they got. And this is the results that we have. When we did the simple random sample, this was the different average yields that people got. When we stratified by row, these were the different average yields that people got. When we stratified by column, however, everybody's results were within 1 or 2 of 70. I think they range from like 69 to 72. Okay, so everybody's results were extremely close to 70. It turns out that if you add up all 16 of these and divide by 16, the average yield per plot, average yield is 70. I don't know if that's 70 bushels of corn or what that 70 represents. This particular example didn't give me any units, but the average yield for all 16 plots is 70. So if we look at these 3 methods, all of the methods pretty much centered around 70. Okay, so if we look at, here's my center, 70, 70, 70. Okay, now this group, it seems like in the simple random sample, people tended to get a few more of the smaller yield side, and over here people tended to get a few more of the higher yield side. Just by random chance, you could end up with more on one side than the other, more closer to the river, more farther from the river. But if we had had a bigger group, we probably would have seen these eventually balance out as people did different random samples. So both of these are fairly accurate as far as they're centered in the right place, but when we look at the variability in the results, these are all over the place, particularly the stratified by row, everywhere from an average yield of about 15 to an average yield of about 130. So the variability makes these results very imprecise and inconsistent. So the stratifying by column, where we actually took into account that the river had an effect, is really the most effective way to do this sample. So how do you do a stratified random sample? It has two steps. First of all, you have to divide the population into subgroups that share a common characteristic within the group. So in our river example, the common characteristic that our group shared here in this best example is the distance from the river. Okay, so that's the common characteristic. Here the common characteristic would have been how far north or south they would on the field. That didn't turn out to be a very effective way to stratify, but stratifying by distance from the river was effective. Okay, then once you have picked the groups, then you randomly sample within each stratum, or within each group, you randomly sample. So the original dividing into groups is done by a certain characteristic. That is not random, but there has to be an element of randomness. Then within each sample, you do a simple random sample. Within each stratum. So when is it beneficial to use a stratified random sample? When there are subgroups with large differences in the value being measured. So when we look up at our corn population, the subgroups are these columns. There are large differences in these columns with respect to the variable being measured, which was corn yield. What is the benefit? The results will have less variation from the true population value. We saw that here, much less variation in that third column, or third method. And how do you choose a variable to stratify by? Well, obviously you can't just choose any old variable. Choosing choosing rows did not help at all. Choosing columns helped. So you want to make sure that you pick a variable that most affects the value being measured. So in this case, distance from the river was most effective. Now, we're going to look a little bit at the next page, because then this talks about another method, which is called a cluster sample. In a cluster sample, unlike a stratified sample, you first divide the population into subgroups that resemble the population, and then randomly select one or more clusters for the sample. Okay, so in our cornfield example, let me go back to the cornfield example. Okay. Actually back here. So if we look at the cornfield, notice that each row here could be a cluster, because each row contains one square that is close to the river, a little farther, and then far away from the river. So each row would be kind of a mini population. It would have a little of everything in it. So what we could do for a cluster sample is number the rows 1 through 4, and then randomly select one of those numbers, and then do all 4 squares in the row. That would be a cluster sample. So I have this written out. Randomly choose one entire row of the cornfield and sample all 4 plots in the row. That's a cluster. Why do we use a cluster sample? Well, the main reason is that the individuals in the sample are all close together. It's more convenient, but still randomly chosen. Okay, so it's not a convenient sample in that I'm just going to pick the things that are closest. I'm going to randomly select the cluster first, but because the cluster is all clustered together, it's closer. So I don't have to travel all over the cornfield. I can just go all the way down one row and get all that information from one row. Now, how is it different than a stratified sample? In a stratified sample, the groups are similar within, but different between the groups. So within each column of the cornfield, there was similar amount of yield, but they were different between groups. So let me go back and let's look at the cornfield again. So within each column, and I might have said row before, within each column there's a similar yield, okay, but big differences between the columns. The cluster, however, are different within but similar between. So within each cluster we see big differences representing the entire population, but every cluster looks pretty much like the other one. Okay? So stratified, similar within, different between. clusters. Similar or different within, similar between. That's the main difference with clusters and stratified samples. Are there any drawbacks to using a cluster? Well, in some cases a cluster might not really represent the population. So let me give you an example. Let's say I want to know, on average, how many books students read over the summer in the English class, the senior English, or the senior class at Covenant. Okay, so how many books did students read over the summer in the senior class? So I decide to randomly sample the seniors by randomly selecting one of the senior English classes and asking everybody in that class how many books they read over the summer. And then I would use that senior English class to represent the entire senior class. Okay. Well, it turns out that that would not be a good idea because not all of the senior English classes are alike. Some of them are AP Lit and some of them are non-AP Lit. So it would be more likely that the AP Lit seniors probably read more books over the summer than the non-AP Lit seniors did. So a cluster in that case would not be representative of the population. So you have to make sure that your clusters really are very similar to one another and that each cluster is representative of the population. If you do have that situation, however, it is much more convenient since they would all be close together and easy to get the sample. So those are the two main other methods besides simple random sample, stratified and cluster sampling.